Hello everyone, my name is Sean Lacey of Lacey Maths and Stats Consultancy, and this video is a demonstration on how to present simple linear regression results. So I suppose you might have gathered if you've watched any of my previous videos on YouTube that I'm not a fan of, I suppose, creating tables manually in Excel or in Word of results that are generated in RStudio. I much prefer that if we can pull all the results together in RStudio and then write them to Excel and then go from there. So I suppose when I do simple linear regression analysis in RStudio is that there's a lot of information sometimes being thrown back, which is all very good, but it's just how do we kind of maybe be some way selective in the information that I might want to use in the table. So just to kind of give you an idea, it would be a case of kind of working towards something like this, of where I might look at presenting the table of where I'd have my correlation coefficient. Now here it would be Pearson because I checked the data for normality. Then it will be the R squared, so it's going to be the coefficient of determination. So 92.4% of the variation in the response measurement is explained by the linear relationship between the response and the explanatory variables. And then the overall p-value for that, for the overall model. And then there would be the intercept, the slope, and then I suppose these are going to be the regression coefficients, and then the confidence interval of, I suppose, the regression coefficient around the slope. And it's just, I suppose, how do I kind of pull all that information together in RStudio and then write that to Excel? And that's what I just want to talk through here with this one, and hopefully just find it of use. And as always, as I'm working through these, if you've comments along the way, then please put in a comment below. You might have your own suggestions to how to format or how to present linear regression analysis results, and by all means please share. It would be more than welcome. Okay, so here what I'm just going to look at doing is I'm going to make a look at 15 numbers, paired values, I suppose. I'm not even going to give any context to this. I'm going to call one of them the explanatory variable, the other the response variable. I'm going to pull them all together into a data frame. So that's the first thing. And then I'm just going to draw a graph, basically draw a scatter plot for this, just kind of get an idea to actually what we're actually looking at. Obviously, I suppose when you look at the table that I just showed you there, it's the table of the regression results. Obviously, before you get to that point, you would be looking at your assumptions. Before you think of presenting your regression model, you look at making sure that your regression model satisfied the assumptions around normality and the variation with the residuals and so on like that. So you'd obviously do those checks. So this is a case of once you actually have your final simple linear regression model, how might you present the statistics, okay? And that's what the focus of this video is how do you present the statistics after you know that your model is deemed reliable and everything and accurate, okay? So this is where I'm just looking at 15 paired values of where there does quite clearly seem to be a nice positive linear relationship. So you've done all the stats behind the scenes to show that there is a positive linear relationship. It is significant. You've satisfied the assumption around the residuals for your model, and now you just want to present your model in a table, and that's what this video is about, okay? So I'm going to just jump straight then to doing the linear regression model. So that's what I have here. So I'm calling it fit. Here's the summary of the fit, and this is all the information then, okay? So this is the information we get, and I suppose want to kind of extract different parts of it. What do I want to get out of it? Well, I want the R squared. I want to get out this 92.4%. I'd like the overall p-value here. Now, obviously, the p-value matches this p-value up here because it's simple linear regression. But when it's not simple linear regression, when it's multiple linear regression, which is what a later video I'll do will be on, this will be a different approach to it. I'd like to extract the regression coefficients here. And I'd also like to get the confidence interval of the regression coefficients. That's something that I'd also like to have. And it's not saying that the table that I'm showing you here is the way to do it. I mean, this is just a suggestion, and I suppose it's more a suggestion to how to to manipulate the information, or to kind of I suppose create script in RStudio that can kind of put a table in the format that you might want it to be in, okay? So that's what I'm basically going to look at doing. So let's see, we'll go back here to this and let's see the script that I've worked out. So it's where you have to, I would feel you have to have an idea in your head to what you're actually looking for, okay? So the picture in my head was this type of table of where I'd have the correlation coefficient, my R squared, and then I'm going to have a label called regression coefficients, and then intercept, slope, and then these two confidence intervals. So that was the picture I had in my head. So then it was a case of I create a vector with these labels to it, and then I look at aligning it with all the actual values. Okay, so that's, I suppose, And obviously it would take a bit of time to kind of set it all up, but then once you actually have it, or what I find once I have it, I've used this on a quite a regular basis. Okay, the only thing I'd probably change is I'd change, instead of saying slope, I'd put in actually what the measurement actually was. Okay, so if I want the correlation, a few ways I could do it, but what I decided to do is I would generate the correlation coefficient. Actually here I am missing the library. Sorry about that. LIBRAY-CH, sorry about that. And then we do this here, and you can get that. So I just forgot to load the library, it's the site library. So you can see here's the correlation coefficient of 0.96. So I want to just extract that. So I'm looking at extracting the correlation coefficient, and I'm rounding it to 3 decimal places. That's what I'm doing here. That's that bit. And then I'm looking at just extracting the corresponding p-value as well. But we can see that the p-value is 0, and I would have said this in previous videos, you wouldn't report the p-value as 0. You would look at saying it's basically if it's how small it is, if you actually have it, if you can state it to a particular value, or else it's less than 0.005. Some people prefer to say less than 0.001, and whatever your preferences, or maybe it's whatever the journal that you've been thinking of submitting your work to might be leaning towards. So I'd write up this if else. So looking at my p-value, if the p-value is less than 0.05, then state it as less than 0.05, or state the exact p-value. So this is what I'm getting back. And then I'm going to look at the R squared. So if I look to extract the R squared, so the model that I've generated, the linear model was called fit. So then if I look at the summary of fit, I can look at summary fit and then extract the R squared value. And here I'm just rounding the R squared. Converting it to a percentage and rounding it to 1 decimal place. That's what I'm doing here, and that just gives me 92.4%. The next thing then I want to do is I want to get the confidence interval. So I can actually just use, I'm just going to make a bit of space here for this, just so you can just maybe see the code, how I'm extracting this if you're not familiar with it. So fit is the linear model that we have. I could do confidence interval of the fit, saying 95% confidence interval, and it will give me this information back. So I want to kind of extract this information, but all I'm really interested in is I'm not interested in the intercept. I'm more interested in the actual explanatory variable, the slope. So I could look at the second row if I wanted to. So I could just do the second row like this. It's just going to give me those. If I wanted to look at particular parts, then I could look at specifying which particular part that I actually want. I could look at specifying it as the 2-1 like this, the second row first entry. That would give me that value. Or another way of doing it is I could actually just label it like 2. Okay, for the upper row, for the lower value, or I could label square bracket 4 for the upper one. So square bracket 2 for the lower, square bracket 4 for the upper. Or I could do it this way as well. Either or will give us the same answer. And so I'll click it here. You can see there's the lower limit and here's the upper limit. So and I'm rounding both to 2 decimal places just to keep it nice and tidy. The next thing then is I want to extract the intercept. What is the intercept? So it's looking at the coefficients of fit and rounding that to 1 decimal place. Again, so if I was just to look at the coefficients of fit first by itself, like this, it's going to give me my intercept and my slope. And here I'm just isolating. What's the first one? Rounding it to 2 decimal places. What's the second regression coefficient, which is obviously the slope, and rounding it to 2 decimal places. That's what we have. Okay. Then I want to just pull all that information together into a variable called statistics, which is basically this column here. That's what I'm looking at doing. So I know here that I need to have my correlation coefficient, R squared, I need to have a blank, and then I need to have my 4 values. And so that's how I'm setting it up here. So you can see here, look, I'm stating the R first, the correlation coefficient, then my R squared, then a blank, then my intercept, the slope, and then the confidence intervals, the various statistics. That's what I have. So that they're the names I'm giving it. Then I want to line up the p-values. So this is going to be the next column. And so this is where, again, I need to have a picture in my head. So I'm going to have a p. This is just merged. I merged this in Excel. But I'm going to output the p-value first. Blank, 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 p-value, blank, blank. That's what I'm kind of looking at doing here. So that's what the script is doing back here. So you can say, look, I'm saying a p-value. Then I'm doing 3 blanks. Now I could have used the rep function, rep, and then done the blanks. But I felt if I just kind of counted them out here, it would just make it that bit more straightforward at the start. And then I'm doing the blanks here as well. That's it. Then I just pull all the information together as the data frame. And what did it not like? Oh, because I never ran off the measures. So I'm just actually going to, as a safety, I'm just going to highlight it all, because just with talking about it, I never actually ran off that first line of measures. So there I have it, and here it goes. Okay, so you can just see here now, that's just a nice concise way, and like everything with RStudio, it takes a bit of time to kind of pull the script together to kind of present the table that you actually want. But once you have the script, it's brilliant. Then you can just use this going forward. And I would generally use this kind of approach when I'm presenting my statistics for a simple linear regression model. And again, and I'm just going to say this again for completeness, you obviously, before you think of presenting your results like this, you've checked your residuals, you've checked that you've satisfied the assumptions around the residuals. Then I'm just going to look at writing this to Excel, and the reason I just want to do this is I just want to show you the small bit of formatting. There's always going to be a bit of formatting in Excel, but it's what you'll see is it's never formatting the numbers. Okay, I'm never looking at typing the numbers. It might be just lining up the cells and stuff like that. Okay, so I'm just going to write it here to Excel, yeah, as table SLR. So I'll go to the folder that I have this in. So I have it here. So here's the folder. Then I open up this. This is perfect. I'll zoom in this a small bit here just to make it nice and clear. And here's now is where I just have to do a small bit, but you're going to see now I'm not going to change anything around that one decimal place here. I'm happy enough with all that. Just this R, I would call it R squared. So I'm going to go insert, put in a symbol. Here's my square. Insert that, perfect. Here I'd look at merging this a small bit. This is then where you can get kind of particular yourself. So I'd look at doing something like that. And the P, I wouldn't do underscore P, I'd do it like this, and then I'd center it like that. And you'd probably look at centering this, because I mean, look, that's up to you, but I suppose this is just to line it up with the table that I had there in the handout here. What else did I do here? Look, I just merged those, that's all, just to kind of make it quite similar. I merged these here, and that's fine. And then I would just make it with a space here, correlation coefficient. I'm happy enough with that. I'd highlight it, format the cells, go to my border, load. Everyone would have their own way of doing this. I'll put the border one as a slight outline, and put this as a slight inside. I'll press OK, and there's the table. I don't need those values, and there's my table. And this is then something that I would look at copying and pasting this then into my Word file. But ultimately what I'd have now is I'd have transparency of how I've generated that table, and that's what I'm getting out here out of RStudio. And I know there's a small bit of playing around with this, but hopefully you can go see that it's not that bad. And I mean, all that will really change kind of going forward then for your own examples would be potentially just the labels that you're going to use up at the very start. And that's what I find for myself. That's all I really do, is I just change the labels that I say here is where I change this to whatever the actual slope is, whatever the measurement is, as in the name of the measurement. And then after that, all these, they stay the same. Okay, so I don't change any of that. And I just find that can be a help, because ultimately it's then about having just that transparency around how you're presenting your statistical results, that you're not looking at creating the table manually in Excel or in in Word, because I just feel if you're doing that, and if you load of I suppose simple linear regression models, and you're going to do this numerous times, you're just running the risk of just making a silly mistake. And this is just nice to kind of have that backup. Okay, and I'm going to do 2 more videos kind of in this overall line, where I'm going to do another video about how we would potentially, it's a suggestion of presenting multiple linear regression analysis results. And then I'm going to look at the idea of doing a model selection, that if you have multiple linear regression, then often what you'd have is you could have multi-collinearity. So how do you kind of select your final model yourself step by step? Okay, so I'm just going to go through those videos as well. Okay, and you'll see them up on YouTube as well. Okay, and like always, like I'd say at the end of my videos, that if you had any comments, maybe the script that I'm using, that you might find that there's a more efficient way of doing it, then by all means, please share, throw it into the comment below. If you find that the information that's in this video of good and of interest, I will hopefully have more videos in the coming weeks and months, that if you subscribe to the channel, then you'll get an update to when those videos are uploaded. Okay, and always, if you do find that it's quite good, that you're happy with the video, then maybe if you like and share it, that would be great as well, just to promote the channel a small bit. Okay, but look, thanks very much for your time. Hope you find it of benefit, and there will be more to come. All the best.